ಬಂದೆ ಪುಟ್ಟ.
Okay, so can we begin, Prakash sir? It's done now.
1 minute.
Okay.
You can start, ma'am.
Thank you, sir. Before we begin, I request all the audience to kindly put off your videos and to stay on mute. Queries, if any, may be posted on the chat box, both here as well as on YouTube, and they will be addressed to at the end of the session. Only the light of knowledge can rid us from the darkness of fear, misconception, and pain. Good morning, everyone. I, Meghna, Assistant Professor, Department of Microbiology, extend a hearty welcome to our respected Principal, Dr. R. Kavyashri, Vice Principals, Dr. Bharati S. and Professor Gayatri Sudhir, heads of various departments, my colleagues from all institutions near and dear, and dearest students at the outset of the guest lecture titled Radical Concepts in Immunology and Medical Microbiology, organized by the Oxford Society of Microbiology. I cordially welcome our guest speaker for the day, Dr. Marashetty Seenappa, former project director of the United Nations. Dr. Seenappa's biodata is truly one of a kind. He has been the president of Association of Former United Nations Personnel in and of India from 2014 to 2021. He has also been the former vice president of Federation of Associations of International Civil Servants, Geneva from 2014 to 2017. For 20 years, from 1986 to 2006, Sir has served the United Nations, including the UN diplomatic representations and UN delegations to the Paris Club and the headquarters of the World Bank in Washington. He has served the first 5 years with the joint WHO-UNICEF nutrition program in Iringa, Tanzania, and the subsequent 15 years with UNICEF. He has been the project coordinator at Tanzania, the head of office at Zanzibar, the coordinator and OIC at Zambia, the Caribbean area office. He has been done coordination in Barbados and also in Suriname, South America. Dr. Seenappa has been awarded with the UNICEF Distinguished Service Award in 2004, World Hunger Award in the year 1991 for the Iringa Nutrition Program by Brown University, New York. He has been the head of UNICEF in Zanzibar from 1991 to 1995, wherein he coordinated PHC, nutrition, malaria, and HIV/AIDS control. He has coordinated the UNICEF support to government and NGOs for HIV/AIDS control in Zambia from 1995 to 2000 and has also coordinated UNICEF support to child rights, youth and HIV/AIDS, and life skills in the Caribbean and Suriname, South America from 2000 to 2004. To look a little into Sir's academic background, he has obtained his PhD from the University of Waterloo, Canada, after his MSc from Bangalore University. Dr. Seenappa has published over 25 research papers in microbiology and has worked as a visiting professor in molecular biology at Bangalore University from 2005 to 2010. Dr. Seenappa has presented numerous awareness lectures on COVID-19, bird flu, chikungunya, dengue, and H1N1 at schools, colleges, and hospitals across Karnataka through the Karnataka Vijnana Parishad. Apart from being a man of such scientific career, Sir has an immense passion for birds, spiders, and wildlife, and he spends his leisure time capturing beautiful moments in nature through the lens of his camera. Sir, it is truly a great honor and pleasure that you are here with us today. And now I request you to take over the virtual platform and address all the young minds that are eagerly waiting to hear from you.
Thank you, Meghna, for your very kind sentiments and words. I'm really flattered. Thanks to Dr. Bharati, as well as to Dr. Kavyashri, whom I know quite well, and also Mr. Pratish for organizing this talk. At the very outset, I would like to make a statement that whatever principles in microbiology we have understood until now, historically, conjointly have come along with understanding of the microbial diseases we have gone through. For this reason, we have two options to learn about these principles. Number one, either to look at only the principles one by one, understand what they are, and then to look at the diseases. The second option is historically look at the diseases that have really baffled, threatened humanity, then understand the principles behind, the pathogens behind, and how scientists have unraveled the secrets behind the interaction between the pathogen and the host. For today, I have decided to take the second option, meaning I will dwell upon few of the diseases that have been historically active. Some we have conquered, some we have not. So by starting with some of those diseases, I will be touching upon the pathogens involved and also the pathogenicity involved and the principles behind the control of such diseases. Let me begin with plague. I think all of you know that plague has been a very historical disease globally. Literally, 1/3 of global population was wiped out during the mid 1348 to 1400, nearly for a century. How did that happen? Why did that happen? What was the curse? The bacterium that caused plague is Yersinia pestis. I think as students of microbiology, all of you are aware of at least the bacterium, Yersinia pestis. But why was it so special at that time? Why couldn't we control it at that time? Were there really microbiologists? Well, I think it's too ambitious to pretend that we did have microbiologists. No. But the beginnings of microbiology to control the pest or the disease was made. Now, let's go into a little bit of a detail. The plague caused 3 kinds of symptoms, and therefore, globally, we recognize what's called as a pneumonic plague that attacked mainly the lungs. The second kind, called as the septic plague or the systemic plague, where the plague pustules were all over the body. The third kind, called bubonic plague, where in the armpits and the pits of the thighs, the lymph nodes were swollen to such an extent that often they would burst. And finally, the patients would die. Ironically, people who wanted to convey to next generation and to next generation what were the symptoms of plague and how people died, they constituted a poem which became a rhyme later on all over the world, including in India. I think all of you recall the nursery rhyme, ring of roses, pocket full of posies, and we all fall down. A lot of microbiology is hidden in this rhyme. Well, in the primary school or in the nursery schools, very mechanically children are taught this. Of course, the teacher sometimes doesn't know what's the secret behind this. Why are we singing this? Is this an Indian song or a global song? Well, it's a global song reflecting the process of the plague and how people die. Pocket full of poses implies that if you put your hand into your pockets, it touches the angles of your thigh and the abdomen. If you have plague, especially the bubonic plague, then the lymph nodes are so swollen, almost like potatoes. So looks like as if you have 8 or 10 potatoes in your pockets. For that reason, the poem says, pocket full of poses. I think it's a very good reflection, very good reflection. And then the last sentence, we all fall down, really means we all die. So by the time we have swollen lymph nodes, the next step is that we all fall down, we all die. I think as nursery school children, the teachers would have even taught us little bit animation, asking us to sing this with animation. And at the end, all children do fall down on the ground to show that they are down on the earth. But just that they don't know the history, the teacher also doesn't know the history. But as microbiologists, I think it's very important. We should recall this and connect this rhyme to plague, and also go on explaining to our own students and friends what this rhyme really meant. So now we understood that, yes, this has been a very dangerous disease, killed 1/3 of the population. Then how did we manage to contain it? How did we manage to contain it? Well, 200 years ago, there were no airplanes to carry people, only the ships. So the ships would carry food grains from one country to the other. It so happened that in Italy, in Venice, the mayor noticed that the ships that came from Asia, the rodents or the rats were dying and people were dying within the ship. And when contamination occurred within the port, it spread to Italy. So once it was noticed that plague was entering through ships, the mayor decided, once the ship arrived at the port, the ship captain was asked to keep the ship away from the port for 40 days. The logic behind this 40 days, that within 40 days, if there are infected rats, with the plague virus through the fleas, the rats would die. If there are people who are also infected through the fleas, people would also die. And after 40 days, there is no trace of plague within the ship. Food grains can easily come. And even if 1 or 2 rodents make their way into Italy, they would not bring the fleas. This 40 in the Italian language, Spanish origin, called Quaranto. So that 40 days of seclusion or isolation is now familiar word as quarantine. So we all use the term quarantine in a different way. Well, interestingly, 40 days, what was the main reason? Why the mayor decided? Well, 200 years ago, somehow always people attached to what happened in the Bible, what happened in Christianity. In the history of the earth, there were floods. Many people were dying. And it was said in Bible that Jesus fasted for 40 days and 40 nights to make sure that people are protected, earth is protected. So somehow that 40 became a magic number. And that's the reason why the mayor also, came out with a suggestion. I think now we are all very clear. The term quarantine continues as transcended over 200 years and it will continue. Quarantine meaning isolation without meeting anybody or anybody meeting you in person. All of you also know that the quarantine now for self-isolation for COVID-19 is 10 to 14 days, depending upon if you're a primary contact or not. Well, what we understood as principle, learning about plague is that yes, there is a pathogen, and this pathogen is a bacterium and it is Yersinia pestis. Does it affect human beings directly? No. It needs a vector, meaning somebody to carry the pathogen. The vector in this case being a flea or an arthropod. The fleas are parasitic. They mostly attack rodents. So there is a match of the flea with the rodent, a carrier of a carrier. And then once the flea comes onto the surface of our own skin, any damage in the skin will be the entry point, And then the pathogenesis begins because the bacterium enters the bloodstream. So 4 principles to be remembered: pathogen, the primary vector, the secondary vector, the entry point, and then the pathogenesis. Well, for the time being, I will stop with plague at that point. So that was a bacterial disease. Now let's go take an example of a viral disease, again historical, and see what we have learned and what principles have emanated from there. All of you as microbiology students know very well that measles is caused by a virus rubella or rubeola. Because it causes blisters on the skin. When the measles was first described in German language, a blister meant measles, and that's how somehow the name measles goes as German measles. But it's not to be misunderstood that the measles attacked only Germany and nowhere else. I think it attacked everywhere, especially Asia. The measles gave skin rash, fever, and red eyes. Skin blisters were all over. Then let me share my own experience coming from a very small town where on a street we were about 30 boys and girls, contemporary, aged around 3 to 5 years, contextual at that time. I'm talking of many, many years ago. During that time, measles was common. In our street, if one boy would get measles in a house, we would know very easily how. When we would like to enter into that house, we leave our slippers outside, number one. And at the entrance of the doorstep, the family would have kept the cow urine and neem leaves. So we would splash the cow urine using the neem leaves on our feet and then enter. I mean, this was many, many years ago. The principle behind that was understood already by parents and their parents was that when there is measles, the child has lost his or her immunity so much that other diseases can come in easily into the house, into the child. So in order to cordon off any more infections, this was the practice. I think that was a very good practice. And secondly, after 10 days that the child would recover, all children of that street are called in and were asked to mingle very closely with this child with, who has recovered from measles. And then, we would be given some snacks to eat. The idea of playing very closely with a recovered child was to ensure that we touch that child very often, get the virus particles onto our skin. The only difference between the virus particles 10 days before for that boy was that 10 days before that virus was very virulent. Within 10 days, it has multiplied so many times. And every time it has multiplied, it has become little bit gentle, little bit gentle. And finally, after 10 days, it was less harmful. So meaning that we were all getting the less harmful measles virus on our skin. And therefore, the process of antibody production or the immunity started in us. That was the principle, but nobody knew at home. Nobody knew at home. I think it's very important to recall that we have had practices which really promoted good health, And I think the scientific interaction would have probably at that time helped us to advocate, understand these principles much better, even before they would go into the textbooks. Then in this connection, let me also recall another viral disease, the Spanish flu of 1918, which killed again millions of people, coincided with the World War One, The reason it became known as Spanish flu, although it was all over Europe and the rest of the countries, including in India, because of the World War time, countries were reluctant to tell the number of deaths. Well, we are literally into the similar situation regarding COVID deaths, the data, nobody wants to believe what government is giving out. They say at least 3 times more or 4 times more, 5 times more, looking at the data from the crematoria and whatnot. So it was a national secret not to give out. But Spain being a neutral country, there was no hesitation. Spain started saying so many people died in Spain because of the flu. So the flu became known as the Spanish flu. So although it was a global pandemic, it became known as a Spanish flu. Well, after that, we have had the chikungunya, dengue, HIV, COVID. I will not be going into the details of any of this, but I think what is really a lesson learned from measles is that we need to understand the virus much more, its behavior. When is it very virulent? How long the virulence will last? How does it spread from a person to the person? Then in this connection, there was also the beginning or a starting of the idea of vaccine. I think all of you know about Jenner, the famous microbiologist at the time in England. He was making observation that smallpox is taking over the world. But look at these maids who are milking cows every day in London. He was staying in a place called Gloucestershire. He noticed that like smallpox in human beings, cows were getting their own pox called cowpox. The cowpox was not easily transmitted to everybody, but only those maids who were regularly milking cows, they were getting blisters. And these were the blisters of cowpox. Jenner got a wonderful idea. Why don't I take out the fluid from such blisters, inject to somebody and then inject the smallpox virus. Let's see if he would develop. It's a young boy by name Pips. So he agreed to be a volunteer. Very fortunately, when smallpox was injected, he did not get smallpox. So Jenner made saying, well, okay, this is the first vaccine in the world, the smallpox vaccine. Here it is. Well, it developed and refined further later on. That's fine. But the milkmaids remained immune to smallpox. I think the principles behind to be learned are very useful, very appreciable, and to be documented forever. Now, interestingly, the Spanish flu, I mean, like the COVID-19 affecting our own political leaders very often, Spanish flu affected even the American president at that time, Mr. Woodrow Wilson. I think you might have heard the name very popularly, Woodrow Wilson, because he started the precursor of United Nations, called as the League of Nations. So anyway, I mean, the principle there is that when it comes to the microbial infections, infection spread, it will not care whether one is a president or a normal man or woman or child. So that was another principle. Then there was also the yellow fever. I'm not too sure if many people have heard of the yellow fever. It's not so much here. The reason why I would like to bring up the name yellow fever here is that many of the viruses cannot be transferred on their own. They will have to depend upon some host or the other. The dengue virus, chikungunya virus, and the yellow fever virus, they all depend upon mosquito. The Aedes aegypti mosquito, the Aedes mosquito is the one which can transmit the virus from one infected person to the other. So the vectors are as important as the microbes, pathogenic microbes themselves. Then, after touching upon disease caused by bacterium, few diseases caused by the viruses, let me touch upon protozoan disease. All of you are familiar as students of microbiology, biology. Plasmodium vivax is responsible for causing malaria in human beings. We have known malaria for more than 150 years. We have tried to produce so many vaccines, but no vaccine has come close to 40% or 50% efficacy, not more than that. The Plasmodium vivax, again, the vector is the Anopheles mosquito. So we get the disease only when the infected Anopheles mosquito bites us. Well, getting malaria is very different. With myself, having worked in Africa a few years, I got malaria a couple of times. It was, not just interesting, but when you take the malaria medicine, I think the medicine was not so good. The chloroquine is very bitter. Very bitter. Its equivalent called Fansidor is not better anyway. So one had to suffer. I think it is still affecting many people in East Africa, and seasonally we come across malaria here. There is what is called cerebral malaria, also caused by Plasmodium, but different variety. It affects mainly the brain. It affects mainly the brain. When the brain is affected, I mean, I have noted in the hospital wards in Tanzania, when I would visit, people with cerebral malaria would be sitting and singing poems or songs. How come? They go into that kind of a poetic mode. And very often, doctors, in order to save them, they of course give them, intravenous infusion of the chloroquine or researching. But then many people do die. Many people do. So I touched upon three things so far. One, measles. Yeah, and then we also touched upon the plague, and then the protozoa. Then the third thing I would like to talk about fungus. Rather than going very historical, let me say something very recent. With COVID-19 or the SARS-2 virus, the infection is very bad, brings your immunity down, brings your immunity down. How do we know? Once the immunity is down, the other infections are very common. The reason why immunity is down, not only just because of the infection, but because the patients go a little bit late to the hospital. I think all of you have been observing. No beds as well in many places. Once they reach the hospital with problems of breathing, many doctors give them steroid, including methoxyrate and whatnot. The reason why they give the steroids, they would like to stop the overreaction of our own immune system. So once the immune system is suppressed, the cytokine storm is suppressed. That's the whole idea. Doctors continue the steroid. So if you continue the steroid at high dose for 2 or 3 days, your immune system is at zero level, completely suppressed. There are what are called as opportunistic infections. Opportunistic infections. Fungal infections are very common. Yeast and other fungal infections are very common. Especially if you're diabetic, which means that your blood is full of sugar. So full of sugar in blood means the water activity of your blood is lesser compared to the others. So this means that fungus will easily come in. Fungus will easily come in. The fungus which is really threatening the COVID patients now is mucor. The most common, I think, starting from pre-university, you would have studied what is mucor, and all of you also know from your work in the kitchen that if you leave bread outside for 2 or 3 days, mucor easily comes up. Sometimes rhizopus, sometimes mucor. Now here of medical importance, mucor is causing what is called mucormycosis. How do people find out? The COVID patients complain of pain in the eyes or pain behind the eyes. And ENT doctors also indicate that if you have running nose with black fluid coming out, it's very clear indication there is mucor. If you do not treat, mucor enters the brain and can spoil one part of the brain. And the only answer to that is to take away that part of the brain. Well, hope let's not be in that kind of a situation anymore. So the principle learned is that opportunistic infections are waiting when our immunity is low. Then let's look at the lessons learned. We also know about H1N1, swine flu, Spanish flu. Where do these microbes enter? Viruses cannot enter by themselves, but viruses can enter other people through droplets from infected people, through droplets, or by touch, or by touch. So the kinds of routes are direct inhalation, blood organ transplantation, congenital from mother to ingestion directly, inoculation, and sometimes through sex or sexual reproduction, sexual contact. Well, when we have so many routes, I think it's very essential. Whatever is in our hand, we should try to protect ourselves. And this is the reason why during the COVID times, we are always being asked to use masks. One mistake we have made, I think, with the COVID-19 situation, we have always been saying use the masks when you are in a big crowd outside. But today, situation is very pathetic. If you take a single family does not have only one person. There are two, there are three, there are four, there are five, there are six. If one person gets infected within a family, within 2 to 3 days, rest assured, all will have the COVID virus. They will all turn COVID positive. Nobody until now had been advising that even inside the house at this situation, you should be wearing masks. You should be wearing masks. That will protect. So that's one principle that we could learn from here. Then let me go into immune responses. Well, whether it is a virus or a bacterium or a protozoa, there is always some kind of an immune response system in our bodies. So the story is, first of all, there is exposure, then there is incubation time and symptoms in our body, various kind. And after that, the immune response in our body, during which process the clearance of the dead or the weak virus or the bacterium or the protozoa. And finally, the result is that we will have immunity, most likely a lifelong immunity. I mean, that is the immune response. If we go to different stages, in immune response, you would have already learned that in the immunity, we have two major kinds. One is innate, something which we are already born with. We have the skin. Then we have the entry points like the nose and the mouth. And then we have the saliva, and we have the natural hair. I mean, all this part of innate, something we are born with, or very protective in nature. And we should be really appreciative and thankful to God that we are born with all this. But then the innate immune system is not enough. Our body has to adapt itself, show response to a pathogen which is passing through all the entire innate immunity, cutting through, and then directly entering into the blood. Then our adaptive immunity kicks in. What is adaptive or humoral immunity? It's humoral immunity because it's somehow the so-called antibodies are in circulation. The most important cells in this regard are two types of cells. I think all of you know. Those that are produced in the bone marrow, called as the B cells, and some of the B cells which migrate to the thymus, mature there as T cells. So the T cells and the B cells are very critical in what is called as the humoral or adaptive immunity. Not only these two kinds of cells, but there are other cells which are very crucial as well. The T helper cells, the natural killer cells, and also the phagocytes at the end. Well, I will not be repeating all this because this is something academic, and you will You will find it in all the textbooks, and it's part of your syllabus as well. Now, in the next 5 minutes or so, I will touch upon COVID. I mean, although I was not planning to touch upon the COVID 19, but let me dwell even before you start asking any questions on COVID. The current situation definitely is very bad, very bad. Many people are of the opinion that the so-called second wave, the virus is milder than that of the first wave. Point one. Point two, of course, the spreading is much more now compared to the first wave. Number three, more people are dying now, not directly because of the virus, but because many other reasons. Number one, awareness is still low. Number two, they are coming to the hospitals very late. Number three, even coming to the hospitals, the infrastructure is so overburdened that hospitals are not prepared with oxygen, not prepared with medicines, not prepared with doctors. So even the so-called first line, attackers of the virus, they are also sometimes frustrated, and there have been cases where doctors have committed suicide, not capable of withstanding these tragedies. So we cannot really just blame the virus for the exaggerated deaths. But the good thing is that in the next few weeks, could be 2, could be 3, the curve of the virus spread is leveling off and it will come down. The vaccine, which should have been made available by now completely, hardly 5% of the population in India is vaccinated. But also, as microbiologists, you should believe this, and the general population should also believe that the virus has been spreading regardless of the first or second wave, spreading to more than 25% of the population, 25 to 30% on its own. So when the virus is spreading on its own, and most people, say more than 95%, are not even showing symptoms, but they are spreading the virus to the others, which means in all these people, natural antibodies have formed. So if you combine the population with natural antibodies forming, plus those who are already vaccinated, I think we are setting up a base to fight this virus. In the next year and a half, we should have good herd immunity so that the new infections become less and less. And the virus is supposed to become endemic and seasonal. Well, I really want to, stop there, but not before reading out my final note. Compared to 200 years ago, where pandemics were rare and they could be enhanced only by ships. Now we have 1 billion people traveling by air annually. 1 billion people. 35,000 ships at sea on any given day. Any disease to be endemic is out of question sooner or later. And every disease is trying to become pandemic, and it's easy now than before. So let me stop at this point. So thanks to Oxford College staff and students for such nice opportunity to meet all of you. Thank you. Mr. Pratish?
Yes, sir. Yes, sir. Meghna, ma'am.
Meghna, ma'am, I think I have another 15 minutes for any questions or discussion.
Sir, I will talk to her, sir. Kindly, please hold on, sir.
All right, sure.
Thank you, sir, for the exuberantly illuminating talk. The forum is now open for questions. I will read out a few questions which have been posted on the chat box, and sir can help us answer.
Okay.
So the first question is from Bharti ma'am. Ma'am would like to know what makes the people affected with malaria to get into poetry writing.
Sorry. Could you repeat, please, Meghna?
Yeah, so you mentioned that when you went to hospitals, when you were working in Africa, that the people affected by malaria were into poetry writing. They would think a lot and write poetry.
Yeah. Okay.
So ma'am wants to know what triggers this act of poetry writing.
Okay. All right. Can I take some more?
Yes, sir.
Yeah.
Okay. All right. Then there's another student who asks that during the 1500s, there was a disease known as the dancing plague, which was caused by, which was suspected to be caused by a fungi. So his question is, are microorganisms capable of affecting our motor skills so effectively?
The question being, if the microorganisms can attack.
The brain,
Oh, okay.
specifically fungi.
Okay.
And then there's another question. When the COVID-19 infection increased in Kerala, at first, as a way to fight against COVID, the blood from recovered persons were taken and injected to unaffected persons so that they could fight against the disease. Is this an ideal way to gain immunity against the COVID-19 virus? The plasma therapy, that's what they're trying to ask.
Okay. So maybe I could answer these three questions first.
Yes, sir, sure.
All right. Yeah, coming to the poetry, we discovered that people who had this problem of singing or maybe going into the mode of the poetry, their central nervous system was affected. The organism had reached the brain through the meninges, activated unwanted brain cells, and that was one reason. Beyond that, I don't know. Second question, the dancing plague. Okay, I also heard about it. This was later on found out to be due to a fungus in people who had lower immunity, and this fungus also affected people with HIV/AIDS because their immunity levels are low. And this fungus is now identified. It's called as Pneumocystis carinii. Then the third question, the Kerala situation. Well, why only Kerala? I think even in Bangalore as well, people were drastically looking for plasma from a person who had recovered from COVID-19. Of course, the plasma would contain antibodies, but the antibodies contained in that plasma, when they are concentrated and injected to an active patient, theoretically it should help. But then when it comes to an active patient, we don't know at what stage that patient is in. If that patient's lungs are already affected, fibrosis has set in, I think it's very complicated. But in principle, it should work. Yeah. But what is not correct is that these antibodies will not, they are not permanent, because they are somebody's antibodies. They come to you and they get destroyed. In fact, your own antibodies will get destroyed after some time. That's why, there were many reports that the antibodies you produce after COVID infection, they will stay for 2 months, 3 months, 4 months, whatnot. Well, it's a natural process, because once those are gone, the memory cells will remember. Memory cells are the ones that become the plasma later on. So what is correct is that this is only a temporary solution. and taking a chance. Sometimes it may work, sometimes it may not. The reason being, if fibrosis has already set in advanced stage, there is no way the plasma can help. Thank you.
Few more questions, sir. One student wants you to talk about lymphopenia, and another one wants to talk about hypersensitivity.
Okay.
And there is a question from one of our staff, Ms. Manasa. She wants to know that currently the coronavirus is of the triple mutant type, and the vaccine which was discovered is not for the present variety or for the present mutant. So how effective is this vaccine?
Okay.
And then can we suppress COVID by taking steroids? Or can steroids increase the chances of being affected by the virus?
Okay, let me start with the last question and go up. The steroids cannot suppress COVID. There is no relation between steroid and COVID. But when it comes to the disease pathogenesis, there is a stage where our own immune system is evoked to such an extent that the interleukins of our body send a message, chemical message, to produce cytokines, and the cytokines are sent in very large numbers to our lungs, which are infected. All this is a chemical message. And it's a self-immune reaction. Steroids can stop this, can suppress this. So that's the relation between steroids and our own immune response, and not really so much the COVID itself. Yeah, that's one. The vaccine, if it is really working on a mutant, I mean, the way I understood this question is that we have been talking in the last 2-3 weeks of double mutations in the COVID virus, double mutations. The old virus, when I mean old, the first wave virus, it was known as N440K in South India, N440K. The vaccine which was made, now let me go back to the details of the vaccine. I think all of you have heard of Covaxin. The Covaxin, when it was produced in India by Bharat Biotech, not long time ago, I mean, hardly 2.5-3 months ago, they used N440K, the whole virus, multiplied the virus in the chicken eggs plenty of times, then inactivated the virus. And this is being now used as the whole virus vaccine. I think it's very important to remember that Covaxin is a whole virus vaccine. If I have taken a Covaxin, whole virus vaccine myself, and then we are challenged with virus with the mutation B1.617 and also the other mutation, I will not worry. Because I have vaccine made from the entire virus. So that's Covaxin. So answer is no, one should not worry, the vaccine will work. But let me use this time also to comment on another vaccine, the Covishield. I am not trying to be biased, which is better, Covaxin or Covishield. But as a microbiologist, if you try to relate and then differentiate, the Covishield is made from a whole virus, but that whole virus is not the COVID virus. It's a related virus, the influenza virus from chimpanzees. Influenza virus from chimpanzees. So the influenza virus from chimpanzees was made to have the extra genes of the COVID, and those genes that were responsible for spike protein. So now we have a chimpanzee virus which has the spike protein genes in it. So that was multiplied plenty of times. It would not cause influenza in us because it came from chimpanzee, but it will evoke very good response for the spike protein when it is used as vaccine. So these are the two main kinds we are dealing with. So I'm not going into the mRNA vaccine, Pfizer and whatnot, but that's my response. Then there was a question on the hypersensitivity. I think already slightly covered it here, but let me also explain. We always think of the immune response to a foreign body. It's true in 99% of the cases. Either the foreign body is a protein or a portion of an organism, either virus or bacterium or fungi, or the organism itself. But in 1% of the times, our immune system reacts to our own particles or molecules being recognized as foreign. And that's when the hypersensitivity comes up, hypersensitivity. There are many diseases also, and these are all the autoimmune diseases, So let me not go beyond that one. But I am not too sure if the person who asked the hypersensitivity was thinking of also the vaccine. Some people develop hypersensitivity on being injected with a vaccine. And it has been found that in most cases, it's not really the virus or the virus particles in the vaccine responsible, but some of the immune modulators in the vaccine that are responsible. Then I'm tempted to ask about this first question again, if it can be repeated, please.
So a student wanted to know about lymphopenia.
Lymphopenia, okay. Lymphopenia is the sudden drop in lymphocytes. Lymphocytes are very important part of our immune system, And if there is a drop in the lymphocytes, you can easily find it out from your blood test. When you look at all this, the profile of the blood cells, then you also see this. So that's a very, very important point. Yes, it's a shortage. It's a shortage of the lymphocytes.
So can we take a few more questions?
Yeah, sure.
So initially when the pandemic began, there was an exaggerated use of hydrochloroquinone. What happened to this is what they want to know. It slowly died out. The use of these chloroquinones has slowly died out. So was it proven ineffective?
Well, initially, I think everybody thought that we had a panacea for COVID. Hydroxyquinone. It's a drug used in malaria control. Even in malaria control, hydroxyquinone is not really such a good medicine. It has a lot of side effects. So people were not really going for this, but going for another malaria medicine called Fansidar, which is safer. So one of the researchers narrated that hydroxyquinone has some suppressive action on the spread of COVID-19. Well, that may be there. but that is not the drug for the COVID. That's not the drug for the COVID. So now it has gradually died out. It has gradually died out. You're right.
Yes, sir.
Okay.
So the question is if it was proven to be ineffective against the virus, if hydrochloroquinone was proven to be ineffective, did they do a lot of research on that and come to a conclusion that it was ineffective?
Sorry.
Yeah, so the question is, was it proven ineffective? Was the drug HCQ proven to be ineffective
Yeah,
against
it was
the virus?
ineffective. Yes, yes, it was very ineffective. There was no way to prove that it was, stopping the replication of the virus. No.
Okay, another question, sir. In the second wave, is the virus more contagious and deadly? If so, why?
Okay. Very good question. Very good question. This, okay, just yesterday, a day before yesterday, in British Columbia, one of the Indian professors who is now in British Columbia, he published a paper. He had taken the virus from the second wave, trying to find out why it's spreading so fast. Of course, from the first wave, we have learned that the spike protein was the key. More efficient spike protein is more efficient with the attachment to the host cell. First wave, it was not so efficient. Second wave, the virus has undergone a mutation. In the gene that was responsible for the spike protein and made it more efficient. So the binding is much better now compared to before. Thank you.
Okay, there's another very interesting question, sir. What is the scope and opportunities for a medical microbiologist after the COVID pandemic?
Can you repeat, please?
Yeah, what is the scope and opportunities for a medical microbiologist after the COVID pandemic?
Well, I think it's as you rightly said, it's a very good question. I mean, right now, the medical microbiologists are wanted everywhere. Yeah. But then the medical microbiologists will not and should not stick to only bacteria and viruses. They should also acquire the skills in biochemistry and the biochemical methods. So right now, the RT-PCR test and the rapid antigen test, they are now being sought everywhere, whether one has COVID or not. So this has really put a lot of stress in the diagnostic field, lot of stress. Secondly, life will come back to normal after COVID. Currently, some of the disease profiles have shifted. For example, continuous wearing of masks has increased in the whole population within India. I think just only 2 days ago, we had the World Asthma Day celebrated. Compared to last year or the year before, the World Asthma Day was a low-key affair because the number of asthma cases in India, especially in the major cities, has gone down by 30 to 40% just because of wearing masks. It doesn't mean that this disease is going away. It will be there. Then after a few years, I'm sure there will be many opportunities for the medical microbiologists. Absolutely, I foresee.
Okay, so many of them have asked this one particular question. Why do we need to take 2 doses of the vaccine? That is the first part. And
Yeah.
they also say that once we've taken the first dose, we are still getting affected by the disease. So is it still necessary to take the second dose? And is it okay to take two different vaccines? For example, if you've taken Covishield in the first dose, and can you take Covaxin in the second dose, or vice versa? So these are the questions which are coming up more frequently.
Okay, I think very, very interesting set of questions. Why two doses? I mean, regardless of the vaccine, whether it is Covishield or Covaxin, two doses are very important. The first dose is more important than the second. The reason being, first dose will confer at least 50 to 60%, 50 to 60% protection, 50 to 60% protection. The second dose will ensure that in the immune system, the plasma cells and the memory cells are formed. Because if you are looking at the number of days from the first dose to the second dose, it's after 3 weeks. It is after 3 weeks that the actual antibody titer may come down, but the memory cells will increase. After all, memory cells are going to be permanent, not really the antibodies. So the second dose is often called as a booster dose. So that's the first part. The second part, can we take a different vaccine for the second dose? No, this is highly objectionable, and it may not serve the purpose, because the first dose, the antigen is different. The second dose antigen is different. So microbiologically, that's not correct, and that's the reason why governments everywhere all over the world insist that you must have the second dose of the same vaccine that you have taken the first time. Then the third part of the question, even after taking the first dose or the second dose, why am I becoming positive? Well, I think you will have to understand very clearly, the vaccine is there as a protection, that when you are infected, the infection will not proceed further to your lungs, which means the vaccine will help us to quickly produce antibodies, and then contain the infection. Just because we have the capacity to produce antibodies, that does not mean that we are immune to getting infected. Infection can come to all, whether you are vaccinated or not. The only difference, if you are already vaccinated, your chance of going to hospital becoming serious is very less, that you are protected. I think that's the difference.
Sir, last two questions before we wind up.
Okay.
Is it okay that if we are not able to take the vaccine, the second dose of the vaccine, because of a shortage in the vaccines? And why is that there has to be a 6 to 8 weeks gap between the first dose and the second dose? Or even if we are infected and when we take the dose of vaccine, why should there be a gap of 6 to 8 weeks?
Okay, I will answer that. The very first dose is actually enough. Second dose may not be needed, but to ensure, our bodies are different, they react differently. The government also wants to ensure a correct practice, and that's why they insist on second dose. But if the second dose is delayed, there should not be any problem. If the second dose is delayed, there should not be any problem. Now, why 6 to 8 weeks? Depending upon if you are taking the Covaxin or Covishield. Covaxin made from the whole killed virus, the real COVID virus. 28 days of gap is enough between the first and the second. That means the immune response is better. Covishield, immune response is little bit slow, but it is still effective. So we need to wait for 6 to 8 weeks for the first dose to prove its worthiness and then take the second dose afterwards. If you are delayed by another 1 week, you should not worry. The vaccines are coming back. The orders are on hand. I am sure in a week or 10 days, they should be there.
Sir,
Thank
can you
you,
tell us
Meghna.
about, sorry, sir, I'm very
Thank,
sorry for interrupting.
all right, Meghna. Go ahead.
Sir, can you tell us about immunosenescence at an early age in healthy people? Immunosenescence at an early age in healthy people.
Immunosenescence. Yeah, sorry. Is it
Yes, sir.
immunosenescence?
Yes, immunosenescence, yes.
Yeah, this is something something very, very rare. The immunity in a child is much better compared to an adult, and an adult has much better immunity profile compared to a old man or a woman. And earlier I mentioned about the B cells which are formed in the bone marrow, some of them migrating into to the thymus and the others maturing within the bone marrow. So finally, we have the B cells and the T cells. The T cells are very critical, very important. Now, with age, the thymus shrinks. Unfortunately, in few people, even when they are a little bit younger, the thymus gland is not functioning well or already shrunken to the size of a green pea, not a thumb. So that uh, precludes them to develop the T cells well, maturity of T cells. So half the immunity is gone. Half the immunity is gone. So that's one of the reasons. But there may be more I am not aware of. But that's what I can think of. Thank
Last question, sir. If
you.
we
All right.
extract the plasma from, if
Yeah.
we extract,
Sorry. Can you repeat, please, Meghna?
am I audible?
No. Go ahead, repeat. Yeah.
Yeah. If we extract the plasma from an individual who has recovered from COVID, can we
Mhm.
purify and clone the antibodies? And if we clone the antibodies, can we possibly use it to fight against COVID in the upcoming times?
Okay, it's a very, very interesting question. The antibodies are very, very well studied. Antibodies are very well studied. I think maybe in few years time, we will have a methodology. We will have a methodology where the antibodies could be formed. But again, one should understand you need antibodies when there is an infection in your body. If there is no infection, if you inject antibodies, even if you make them in the lab, inject them, it will be of no use. It will be of no use because the antibodies have a half life, maybe 2 weeks, maybe 3 weeks, maybe 4 weeks, and then they are gone, perished. But if you have the memory cells in you that were B cells before, and that B cells had produced the antibodies, and this is how to make the antibodies and when the antigen arrives. So then you have a better system than the antibodies itself. Thank you. Okay, thank you very much, Meghna and the Oxford.
Thank you very much, sir, for having answered all the queries that were posted in the chat box. We have now reached the end of the program and it is time to propose the formal vote of thanks. Firstly, I would like to take this opportunity to place on record a hearty thanks to the management of the Oxford Group of Institutions for their support. We have been fortunate enough to be backed by our dynamic principal, Dr. R. Kaveshri, to whom I would like to extend a heartfelt gratitude for her constant guidance. Dr. Sinapa's motivation towards science and his love for students are commendable. I am deeply humbled to say that Sir always readily accepts our invitation to address the students and fellow colleagues at the very first approach. The Department of Microbiology would like to express a huge degree of gratitude to you, sir, for being with
Thank
us
you.
today
Thank you.
amidst your bustling
Thank you.
schedule. We are highly grateful to you and would be much delighted to have more such associations with you in the future. I am sure our students also are very fortunate to be listening to you. I once again thank you for joining us today, sir.
Thank you very much, Meghna. Appreciate. So I also enjoyed the interaction. So wish everybody good luck. And I also urge everyone to not to hesitate taking the vaccines. You must all take vaccine. I think that's the only way you can protect yourselves. And you try to advise all your friends and family members to go for the vaccine. Thank you.
Thank you, sir. I also express my sincere gratitude to Professor Gayatri Sudhir, Vice Principal Administration and IQSC Coordinator, and her team for their encouragement and support towards all the endeavors of the department. I must mention a deep sense of appreciation and regard to Dr. Bharati S., Vice Principal, Dean Academics, Professor and Head, Department of Microbiology. Ma'am is truly the greatest pillar of strength and support for all the strategies, activities, and achievements accomplished by the Oxford Society of Microbiology. I would like to express my sincere thanks to all the participants who have virtually joined us today to gain knowledge from such an eminent person. The organizing team of this program, which includes the very motivating and dedicated faculty of the Department of Microbiology, are highly regarded for their enormous efforts and support in the meticulous planning and smooth execution of this event. I take this opportunity to thank each and every one of them. The feedback link has been posted on the chat box. I request all the participants to fill it out and let us know your thoughts about the program. Thank you all for joining. Stay safe, stay strong, and have a good day.
Okay. Thank you, Meghna. I'm logging off.
Sir, thank you very much for
Thank
joining.
you. Thank you. Logging off. Thank you.
Students, the meeting will be on for another few minutes. You can please fill up the feedback form.
Oh.
Akshata, are you there in the meeting still?
Yes, sir, I am here.
Akshata is there. Akshata and Pragat sir is there.
Yes, sir, I'm there. Prakash sir is also here, I think.
Okay,
Can we
thank
stop
you.
there,
the
sir.
meeting?
Thank you so much, both of you, for supporting for this program. It went on very well. Really, high regards to both of you. And special thanks to Meghna for supporting and doing it so fantastically.
Thanks to you, Pradeep sir, for always standing by me and
Thank you, sir.
helping me conduct this.
Thank you,
Can we
sir.
leave? Prakash sir, you can stop the streaming, I think.
Okay, ma'am.
Thank you, Prakash sir. Thank you, Akshata ma'am.
Can I end the session?
Yes, Prakash,
I'm
ನೋಡಿ.
ending the session.
ಏನು
Yeah,
ಮಾಡಿ
yeah, yes.